I'm going to work out your practice test or a review for the test. This would be over Unit 6, the Chapter 2 in the Big Ideas book. First problem. Talks about a parabola having an axis of symmetry y is equal to -4 and passing through the point 2, -1. And we need to find another point that lies on the graph of the parabola. So let's draw a quick diagram, see what we have. So it has an axis of symmetry of y is a -4. So if that's the axis of symmetry, this parabola is going to be opening left and right. And it's got a point 2, 1, 2, -1 that is on the graph. So 2, -1. And then that point will be actually 3 away from the axis of symmetry because it's 2, -1. This distance right here must be 3. So I'm going to have another point at 2, and it would have to be 3 away from the axis of symmetry, so that would be 2, -7. So the point, another point that lies on the graph would be 2, -7. Okay, we are going to come up with a rule, which means an equation that describes this transformation here. And so let's just do y is equal to, and we're going to have some value of x, and it may have something added to it or a shrink or something. And the first thing it says is it's got a horizontal shrink by a factor of 1/3. Okay, a horizontal shrink. That would be a shrink this direction. So that would be an x shrink, and it's shrinking by a factor of 1/3. Now remember that when we're dealing with the x value, it's actually what the x multiplies by is the reciprocal of what's in parentheses with the x. So if it actually shrunk by a factor of 1/3, that means I'm multiplying x by 1/3 when I make the graph. So this must be 3x inside the parentheses. And then it's going to have a translation of 1 unit up. So that would be, and I need to put my square there, and so that would be a shift upward in the y direction. So that would be my equation. Next one. We have a reflection in the x-axis, so that means it's going to reflect over the x-axis. So that would have to be a y reflection. So here's my equation. So if it's going to be a y reflection, it's going to have a negative outside of the parentheses. It's got a vertical stretch of 3. Okay, vertical stretch. That's a stretch in the y direction. So that does not take the reciprocal. It's just exactly what it says, so it would be a -3. A reflection in the y-axis. That means it's going to be reflected over the y-axis. The y-axis is this direction. If it's reflected over it, that would be a reflection that would change the x value, so that would be a negative. And a horizontal stretch of 2. So now then we have a horizontal stretch. So again, the horizontal stretch would be a stretch going this direction. And if it's stretching by 2, which means in the graph I'm multiplying by 2x, that means in the actual equation I would have to have 1/2 x. So that would be a horizontal stretch of 2. And then it has a translation 5 units down. That would be a y shift 5 down. Okay, next one. Identify the focus, directrix, and axis of symmetry. Okay, so this doesn't have an HK, so it's going to be at the origin. The vertex will be at the origin. So what we have is we have x is equal to a -1/20 y squared, and that's of the form x is equal to 1/4p y squared. So 1/20 must be 1/4p. Now I could switch that around and find what p is equal to, but you could probably just look at it and realize that P is equal to 5. Okay, so what we have here is we have a parabola, and it is an x equals y squared, so it's opening left and right, and notice the negative, so it's opening to the left. And then we have P equal to 5, which is actually, since actually this was a negative 120, so let me go ahead and put that in. So that would be a negative here, and P would be actually equal to a negative 5, which means the focus is going to be shifted this way 5. So the focus, you can see, is going to be at negative 5, 0. So let's start writing down what we know. Also, the directrix would have to be 5 the other direction, so that's x equal to 5. So I have the focus. That's going to be a negative 5, 0. I have the directrix, which we said is a line, x equal to 5. And then the axis symmetry would be passing through the vertex. That would be the line y equal to 0. Okay, what are the x-intercepts and vertex of this equation? Well, the x-intercept for this part would be what makes this go to 0. X minus 5 equal to 0. X is equal to 5. And what makes this go to 0? X plus 2 equal to 0. X is a minus 2. Okay, now to find the vertex, so that's where the intercepts are. So let's list them in point form. The intercepts are going to be at 5, 0, and a negative 2, 0. Okay, now let's find the vertex. So halfway between these 2 points is where the line of symmetry is going to be, and the vertex is going to lie on that. So let's average these 2 points together to find the x value that lies between them. So I've got 5 plus a negative 2 all over 2. That would be 3 all over 2 is equal to 1.5, or 3 over 2. So the x-coordinate of my axis of symmetry is going to be 3 over 2. So I'm going to go ahead and put that in there. Vertex, the x-coordinate is 3/2. Now let's find the y-coordinate. So to find the y-coordinate, I'm going to put 3/2 or 1.5 into this equation. So we would have y is equal to a negative 2 times 1.5 minus 5 and 1.5 plus 2. Y is equal to a negative 2. 1.5 minus 5, that's going to be a negative 3.5, and this would be a positive 3.5. So let me calculate those. And I got 24.5. So what I have is the vertex is 3/2, 24.5, or I could say that would be equal to 1.5, 24.5. Okay, the next problem says to write the equation of the parabola. Okay, we have 4 kinds of equations that we're going to be dealing with here, so let me move this up. We're going to have those that open left and right, so we have the ones that are left and right. And the base equation would be x is equal to 1 all over 4p y squared. And then one, if it has a shift, is going to be x is equal to 1 all over 4p y minus k plus h. So notice that in this case, it's opening. These are opening left or right. That would be a parabola that looks like this. That actually the k is in parentheses with the y, and it's being squared, so the k is the opposite sign, and the h is the same sign. That's different than what we normally see in parabolas that open up and down. Those would be of the form y is equal to 1 over 4p x squared. That's what we're used to seeing, is an x squared. And of course, when it's shifted, that would be y is equal to 1 over 4p x minus h plus k. Right? That's what we're normally used to seeing. Something like that. So anyway, the first parabola I have opens up and down, and it's going downward. So there's going to be a negative. And let's take a look at what I have. I have a p-value that, if you can see that here is, oh wait, here's the vertex right there. It's kind of confusing. So the vertex of this is going to be equal to 0, 2, and so the p is the distance between the vertex and the focus is a -2. Notice that it's going downward, so p is equal to a -2. So I have that much, and we can see, since the vertex is at 0, 2, we can find out that k is equal to 2, h is equal to 0. So using my equation form, since it's opening downward, it's going to be a y type is equal to 1 all over 4p x minus h squared plus k. And let's stick in the values. So y is equal to 1 all over 4 times a -2. Then I would have x minus h. We said h is 0, so that's just going to be x squared plus k, and k is 2. So writing that in a little better form, I would have y is equal to a -1/8 x squared plus 2. The next one is opening left or right, and the vertex is at 0, so that makes it a lot easier. So here's the vertex at 0, 0. It's opening to the left, and we can see the focus is actually 2 to the left, so p right here, p is equal to a -2. So my equation form, since it's opening left to right, is going to be x is equal to 1 all over 4p y squared. Let's put p equals a -2 in there. X is equal to 1 over 4 times a -2 y squared. So x is equal to a -1/8 y squared. Okay, let's try these two. And this says write the equation of the parabola, but notice that this doesn't have like a focus or directrix. This is just simply finding the equation, knowing a couple points. So let's see what we have. Okay, so for this one, we notice that we have a vertex here. So this is the vertex, and that is going to be at a -5, 1. And so if we plug that into vertex form, right, this is if we have a parabola given to us and we have some points and it's in vertex form, we can write the equation of that parabola. It's called modeling. So we'll say y is equal to some value a, x minus h squared plus k. And I'm going to plug in the vertex for hk. So h is a negative 5, k is 1. So y is equal to a, x minus a negative 5, and k is 1. Okay, now what I'm going to do is I'm going to pick one of the points that I have given to me, because that's got to be in this equation. That has to make it true. So I'm going to pick one of the points, plug it in for x and y, and I'll be able to find a. So I'm going to pick this point right here. That's a negative 6. Well, they got these axes on that. Hold it. Oh, this is all wrong because of the way they've got the axis set up. So actually, this vertex is a negative 1, 2, 3, 4, 5 in the x, but it's going up by 2's in the y. So let's plug that in. Y is equal to a x plus 5 plus 2. This point over here will be at a negative 6, 4. So I'm going to plug that in for the x and y. So 4 is equal to a, negative 6 plus 5 plus 2. 4 is equal to a, negative 1 plus 2. Let's subtract 2 from both sides. 2 is equal to a times a negative 1. Dividing by a negative 1, I'm going to get a is equal to a negative 2. So plugging a is equal to a negative 2 into this equation, I have y is equal to a negative 2, x plus 5 plus 2. And these should be squared. So that's going to change my value. So let's try it again. So I have 4 is equal to a times a minus 1 squared plus 2. 4 is equal to a negative 1 squared is 1, a plus 2, and subtracting a from 2 from both sides, I get 2 is equal to a. So y is equal to 2, x plus 5 squared plus 2. Okay, the next one is going to be similar, except that it's going to have a different kind of equation. Now, we haven't really studied this too much. In fact, not at all, but this would be this kind of equation. X is equal to a, y minus k squared plus h, where hk is my vertex. And the vertex is going to be, I'd hate when they do the scale and change it, but now it looks like it's going by ones, so this vertex would be a negative 1, 1. So plugging that in, I would have x is equal to a times y minus the k, y minus 1, plus h, and h is a negative 1, so that'd be minus 1. Now I'm going to need another point to put in, and don't forget this is an x equal to y squared, so it's going to be backward from what we're usually looking at. So here I have a point at 5, 0. Let's plug that in. So the x value is 5. I've got a, and then the y value is 0 minus 1 squared minus 1. 5 is equal to a minus 1 squared is going to be 1, so that's just going to be 1. And when I move the 1 over, I'm going to get 6 is equal to a. So this equation will be x is equal to 6, y minus 1 squared minus 1. Okay, the next problem is going to be identify the focus, directory, and axis of symmetry of this particular equation. Look, it is a function. It is y equals x squared. That shows us that with a function. Then graph the equation. So the first thing I have to do is find P. This does not have an HK, so the vertex will be at the origin. And so I know that 1 over 4P must be equal, because here's my equation form. Y is equal to 1 over 4P times x squared. So 1 over 4P must be equal to a negative 1/12. So if we look at this, P must be equal to a negative 3. Okay, so the focus of this, well, let's go ahead and graph it first. So P is a negative 3. It's going to open downward because it's a y equal to x squared. So my focus, if here's my vertex, it would be downward 3. So here's my focus. So my focus is going to be at 0, negative 3. The directrix would be 3 on the other side. And the directrix then would be, this would be the y equals to 3 would be the equation of that of the directrix line. The axis of symmetry, well, we can see that it's going to be opening downward, so the axis of symmetry is the line x equal to 0. And let's go ahead and graph it now. So we're going to need to come up with some points for x and y. So we always want to use the squared value. We pick the squared value and find the other value. So this times x is squared. So I'm going to pick x and find y. And since 12 is my denominator, I'm going to think of some number that's going to be easy to use. So if I pick x as 6, I would have y is equal to a negative 1/12 times 6 squared. That would be a negative 36 all over 12. That'd be a negative 3. And if I pick x as a negative 6, this is going to come out with the same value because the negative 6 would be squared. It's going to be a negative 3. So I have 6, negative 3. And then I have negative 6, negative 3. So I'm ready to draw the parabola. It would look like that. Okay, we have a word problem. It says your class councils determined its profit from the homecoming dance is directly related to ticket price. Look at the past dances. The council determined that if profit P can be modeled by this equation, where T is the price of the ticket. So this is the equation that represents the profit, and T is the price of the ticket. What should the price of a ticket be of the homecoming dance to maximize the profit? So we know that what's going to happen is the maximum, because this is a parabola that's going to be going downward because of this negative a, that the profit will be maximized at the vertex. So we need to find the vertex of this particular problem. And if I look at this, remember a will be a negative 12, b is equal to 480, and c is equal to 30. So my axis of symmetry and the x-coordinate of the vertex is going to be at x is equal to a negative b all over 2a. A negative 480 all over 2 times a, which is 2 times a would be a negative 24. and that's going to be equal to 20. So what I plotted going this way was T, that was the ticket price, and from that I get the profit. So what I found was that T would be equal to 20. So the price of the ticket should be equal to 20, right? So T is equal to $20. Now I'm going to go ahead and do another part just in case it asks. It could have said, then what was the profit that they made? Well, then I would have to take this value of T and stick it into the equation, and we could figure that out. So let's go ahead and do that just for the practice. So the profit is going to be equal to a negative 12 times 20 squared plus 480 times 20 plus 30. That would be equal to a negative 12 times 400 plus 480 times 20 plus 30. And I got an answer, $4,830. Okay, in this one we're going to be doing a graph, and it looks like it's in vertex form. So let's go ahead and plot that. So what we would do is we can read the vertex right off the graph, right off the equation. H is equal to 2, K is equal to 4. So my vertex is going to be at 2, 4. And this is going by ones. Now I need to find a second point. So I'm going to pick some value for x that I think will work, and then I'll find the y. And so let's just go ahead and pick a value of x equal to 0. I think that's 2 away from this x value. That should probably be good. So plugging 0 into the equation, I've got y is equal to a negative of 0 minus 2 squared plus 4. That would be equal to a negative 2 squared plus 4. A negative 2 squared is going to be equal to 4, but there's a negative in front of it, so that would be a negative 4 plus 4 is equal to 0. So my second point would be 0, 0. Now then I can use my third point. I could use the mirror of that point, and that would be 2 on the other side of the axis of symmetry. So that would be 4, 0. So we always label our points and we draw the axis of symmetry. So the axis of symmetry is the line x equal to 2. I have a vertex point that was at 2, 4. I have this point over here that was 0, 0. And I have the point 4, 0. Let's go ahead and draw it. And that's my parabola. Just to get practice, the domain would be all reals. And the range would be all real numbers that are less than are equal to 4. So we would write that coming from a negative infinity and going up to a positive 4. We have another graph. This is going to be a standard form graph. So if I look at this equation, A is 1/2, B is 2, C is 4. So let's figure out the axis of symmetry. And that's going to be x is equal to a minus a b all over 2a. X is equal to a minus 2 all over 2 times 1/2, which would be equal to 1, so that's going to be negative 2. The second thing I'm going to do is from that x value of a negative 2, I'm going to figure out where my vertex is. So I need to put negative 2 into the equation. So I would have y is equal to 1/2 times a negative 2 squared plus 2 times a negative 2 plus 4. That would be equal to 1/2 times 4 minus 4 plus 4. That would be 2 minus 4 plus 4. A negative 2 plus 4 gives me 2. So my vertex is at a negative 2, 2. Okay, now I need to pick another point. And normally I would pick a point probably a little bit higher up, but this 4 will be my y-intercept, because if x is 0, that leaves me with y equal to 4. So my y-intercept is 4, and since I think I'll plot that. So my second point is where x, now I have, because the scale that they show here doesn't go up to 10, so normally we have a larger scale on our graphs. So anyway, if I pick a second point of 0, I get 4 for y, so 0, 4. And then I'm going to go ahead and pick my third point, and I'm going to use the mirror. And I'm going to get over here. So let's see, let's go ahead and label these negative 2, 2, 0, 4. And now I will have a negative 4, 4. Let's draw the graph. Let's put our axis of symmetry on there. Then the last thing we have to do is say where is it increasing and where is it decreasing. So we can see that this parabola is going downward on the left side of the axis of symmetry. So it's going down. So for the values of x that are less than a negative 2, that's the left side, we can say that it's decreasing. So it's decreasing where x is less than a negative 2. Then once we get past the negative 2, we're starting to go up. So on the right-hand side of the axis of symmetry, we have where x is greater than a negative 2. And if I wanted to write that in interval notation, I could do it like this. So where x is less than a negative 2, and it can't equal a negative 2. So that would be how I could write those values in interval notation. Okay, word problem? Okay, for this problem, it's finding the equation of a parabola again, and we're given stuff with like focus and that, so we're going to use the equation for the focus of a parabola, and we can see that we actually have a vertex that is not at 0, 0, and it's opening down. So this is the equation form that we would be using. So it would be y is equal to 1 all over 4p. Then I would have x minus h squared plus k. And it gives us the vertex is at 0, 3. So h is equal to 0 and k is equal to 3. Okay, so we know that much. Now let's find the value of p. So what it says a light from the searchlight is located at the focus. So the 0, -1, this is the focus right here. And here's the vertex. So what we see is that actually the focus is a -3 down from the vertex, right? So that means that P would be equal to, we're down 3, 4, we're actually down 4. So P is equal to a -4. So let's go ahead and plug our values into this equation. And what we have is we have y is equal to 1 all over 4 times a -4, because -4 is P. Now then we have x minus h, and we already said that h is 0, so that would be x squared, and then we would say plus k, which would be plus 3. So my equation would be y is equal to -1 over 16 x squared plus 3. Okay, the last problem here, I think it's the last one. It looks like a modeling problem, and we're going to be modeling this equation that talks about trout, and let's see what form we should use. We could use the AX standard form because we have 3 points here, and so I could do that. But let's take a look. Look at this. I have 2 y values that are 0. So actually what that tells me is that I have the places where this thing is going to cross the x-axis. It's going to cross the x-axis at 0, 0 and 10, 0 out here. So those are my x-intercepts. So I could use intercept form. And then I have a second point, or another point on there, so we could use intercept form. So let's go ahead. Y is equal to a, x minus p, x minus q. And let's put in the value of our intercept. So we have y is equal to a, x minus p, and x minus q, which in q would be 10. And I can rewrite that. Y is equal to ax times x minus 10. Now we're going to find the value of a by using the numbers that we have for the other point, which is 4, 125. So let's put 125 into y. Let's put 4 in for a. Let's put 4 in for x. And we'll figure out what a equals. So 125 is equal to 4a times a -6. I have 125 is equal to a -6 times 4 is a -24a. Divide both sides by a -24. I get 55.21 negative is equal to a. So let's go ahead now and plug it in the equation. So y is equal to a -5.21 x, and I don't need to put that in parentheses, x times x minus 10. It's the equation of my line, of my parabola. And that should be all the questions.